Now, let's move on to the next two cases. So we talk about gaining, losing oxygen, gaining, losing hydrogen. The next one we talk about electrons. It's about the gain and loss of electrons. So if you gain electrons, okay, this is considered reduction. Okay, if you lose electron, this is considered oxidation. So what are some of the cases? So let's look at here. Okay, let's scroll down furthermore. So we can consider something like this. Oh, sorry. Let's go back. Okay, let's consider something like this. So example, if I have a sodium atom, okay, let's not use sodium. Sodium is too big. Let's try a lithium atom. Okay, lithium atom, how does it look like? Lithium has 2 electron shells. First shell has 2 electrons, 1 electron. Now, when lithium becomes a lithium plus ions, what happens? The lithium will actually lose the outer shell. So this electron over here is thrown away, given out. So this lithium now only has 2 electrons left. In this case, how we're going to write it is plus 1 more electron. So plus a cross here. Okay, so you can see that the lithium from here, this case here to here, okay, from 3 electrons, it has become 2 electrons. So there's a minus 1 electron. This is considered a loss of electrons. So this is considered a oxidation. The next case, we can look at this. So sorry, let's go back. Example. Next one, we can look at a chlorine. Sorry, chlorine is too big once again. Let's try something else. Let's try something simple. We try maybe a fluorine atom. So fluorine atom looks like this. It has 2 electron shells. First shell filled with 2, second shell filled with 7. Okay, what's going to happen is 1 electron from somewhere else will come here. So what does it become? Okay, what does it become? So this F will become a F minus. So how are you going to draw it? 1 shell, 2 shell. Okay, maybe I shouldn't use a cross there, use a dot to indicate it's an electron from elsewhere. Okay? Minus. So you can see here actually that an electron is added to fluorine. Initially, it has, let's use blue marker. Initially, it has 1, 2 plus 7, 9 electrons. After that, down here it has 10 electrons, so it has plus 1 electron. If it gains an electron, this is considered a reduction. So you can see by definition, loss of electron is oxidation, gain of electron is reduction. This is another way to define redox. And the last one that we're going to talk about, okay, which is the fourth case, is known as the oxidation state. This is something more complex, but it's the most useful among all of them. So if there's a, in this case we don't care, maybe we might not use the word gain or loss, maybe we can say an increase in oxidation state. Okay, oxidation state is considered a oxidation. A reduce in a drop or decrease in oxidation state this is considered reduction. Okay, so oxidation state talk increase and decreasing. So the fourth case we talk about is the oxidation state. What are some of the rules to help us determine the oxidation state? Okay, now, so just take note of this. Okay, there are 4 simple rules that you can guide yourself. First, oxidation state. I mean, let's put it simple. Rather than say oxidation state, let's say OS now. Just take note, OS stands for oxidation state. Oxidation state of elements. Okay, I will say elements on its own is 0. So example, Cl2, sodium, lithium, copper. All of this element is on its own, okay, meaning that it's not attached to any other element. F2O2, okay, it's the elements on its own. All of these, the oxidation state is 0. So that's the first case here. The second case is the oxidation state of a simple ion is equal to the charge. So for example, if I have a lithium plus, the oxidation state is +1. If I have a Cu2 plus, the oxidation state is +2. If I have a F minus, the oxidation state is a -1. So you can see it just simply follows the charge. So plus, +1. 2 plus, +2, minus, -1. Okay, so the oxidation state follows the charge for a simple ion. Okay, the next one is quite interesting. We talk about the sum of all the oxidation state of the elements for a substance, okay, is equivalent to the charge. So example, Mg. Oh, what's the overall charge of this substance? Overall charge is 0. Okay, how do we actually get the overall oxidation state to be 0? Because Mg, we know that Mg is actually a Mg2 plus. Oxygen is actually a O2 minus. So what's the oxidation state of Mg2 plus? We know that is a +2. Plus, what's the oxidation state of a O2 minus? -2. So the overall will add up to a 0. We can have another example. Maybe we can try is we try Na2O. Na2O is made out of 2 Na plus and 1 O2 minus. So how do you calculate the overall oxidation state? Definitely overall the charge is 0, so it must be equivalent to 0. But why? Because there's 2 plus 1, okay, 2 sodium, so there's a 2 times +1, plus 1 minus 2. So you can see 2 sodium, so it's a 2 times oxidation state of +1, and 1 times oxidation state of -2. Overall, you add up, it will be a 0. So these are compounds where it is neutral. How about this? OH minus. Interestingly, how do you get it? The O actually exists as a O2 minus here, and the H actually exists as a H plus. So when you add them up, what's the oxidation state? So we know that OH minus is made out of, okay, 1 times -2, because 1 oxygen, the oxidation state is -2, plus 1 plus 1, okay? 1 hydrogen with oxidation state of +1. If you do a mathematics, overall the oxidation state is a -1, which is equivalent to the charge. We can try another one. So example would be a good one is we can try is maybe we try a carbonate, CO3 2 minus. Okay, interestingly, we know that oxygen is always 2 minus. Okay, this is always a O2 minus. So we don't know the oxidation state of carbon. So in actual fact, maybe we can use the oxidation state of carbon is as X. So X, how many X is there? 1X plus 3 times -2. Overall must be a -2 because the charge is a -2. So if you do some simple mathematics, you realize X is equals to a +4. So we know the oxidation state of carbon must be +4. Okay, oxidation state of carbon is a +4. So we'll go into more examples in the next part.